All right, we're going to go ahead and do talk about fractional exponents, and this is Algebra II Semester 2 2.7. As you can see, I went ahead and I just grabbed the checkout problem, made this one a little bit more straightforward. So let's just jump into it. I'm going to go ahead and rewrite the problems because they're kind of blurry on my end, so I'm not sure what it looks like for you guys. So we have a problem: 25 squared raised to the 1/4 power. All right, so I'm going to adjust this so I get a better writing surface on my tablet. All right, so our rule is if we have just a base b, the x to the m power to the n power, if we have this scenario, what we're able to do is we simply multiply. We multiply the exponents. So it's b to the m to the n. So you just multiply the exponents. Anytime you get this scenario, you multiply the exponents. So this is simply going to be 25 2 times 1/4, which is going to be 25 to the 1/2 power. Now, 25 to the 1/2 power is going to become a square root. So this is actually the square root of 25. 25, anything to the 1/2 power is the same as a square root. So this is as simple as being 5. That's my answer, 5. 1/2 power becomes a square root. Now let's go ahead and get the next problem here. And I wonder if let's go on the other side. So let's do red here. We're gonna have the same rule. So I'm gonna have 8 squared to the 1/6 power. Same idea as I'm gonna go ahead and multiply. So it's 2 times 1/6, which is 8 to the 1/3 power. Now, 8 to the 1/3 power, which we could plug into a calculator if we wanted to, but this is also the same as the cube root. Notice how the denominator of the fractional exponent, becomes the index of the root. So the number here is the index. If we go back to our other example, 2 was my denominator, and then it's a square root. Now, what we don't write in the square root, even though it's there, is a 2. There's a 2 in this little index. 2 is the index. We just don't write it because the square root is our default. It's our common one. So we don't write it. But whatever the denominator is, in this case a 2, that becomes the index of the root. In this case it was a 3, so it became the cube root of 8. And you can use calculator or just knowledge base. This is going to be 2. All right, so now I'm going to change. We'll go to number 6. And actually, I'm going to just test something here. I've never done this. So this is 27 to the 5/3 power. So what I can do is I can rearrange this a couple different ways. First thing I could do is, all right, so my denominator is 3. Well, anytime my denominator of a fractional exponent is a number, right, I can make that an index. Whatever the denominator of a fractional exponent becomes the index. So I'm going to have the cube root of 27. Well, then I take that 5, which is the numerator of the fraction, it just goes outside. I'm just to the 5th root. Or I could write it like this. Oh, shoot, sorry. 27 to the 5th power. And then the cube root's inside. So it doesn't matter. You could do it either direction and they both work. Well, I know the cube root, so I'm going to go to the left side. The cube root of 27 is 3. So this simplifies down to 3 to the 5th power. All right, so I was able to take the fractional exponent. I broke it down based upon numerator and denominator. The denominator becomes the index of a root. The numerator becomes just your regular exponent. It's just there normally. The only thing that really is kind of different would be that denominator. It becomes the index, becomes a root. And then 3 to the 5th power is going to be 243. Boom. That's excellent. And it's that kind of straightforward. A lot of these are, we can calculate these as well. Using the calculator, I mean, once we get to these certain points, like the cube root of 27, there's cube root on Desmos if you need it. So let's do, I'm looking at these examples. Let's go ahead and we're going to do 9 or 10. Let's do 9 because 9 looks tricky. So I'm going to kind of come over here. I'm going to write 9 down. So this is a negative 5 to the 8/3 power raised again to the 3/4 power. So what I'm going to do is I'm going to use that first rule that we use. Is I'm going to go ahead and I'm going to multiply my exponents. So this is 8/3. If I could write it legibly, I apologize. 8/3 times 3/4. And this is going to be, well, these 3's cancel, then I have 8/4, which is just going to be squares. This actually ended up being pretty simple. So it's 5 squared. 5 squared is 25. All right, so we do the square first, and we have a negative out here. We make it a negative 25. Let's see if the other one is a little bit, there's a little bit more to it. So we have, and there might be, we'll see. So we have 2 to the 6/4 power raised to the 8/4. So same thing, right? The first thing, we have an exponent to an exponent, power to a power, is we can go ahead and we can multiply. I do believe 48 divided by 16 is just going to be 3, right? So excellent. And then, so this actually is not the example I kind of wanted. So, and 2 times 2 is 4, times 2 is 8. So the answer here is 8. All right, so actually, but, so it looked super complicated to start, and we were able to just do our one simple multiplication, and it ends up simplifying our exponent to something that's more manageable, something that we're more used to seeing. I'm still going to go ahead, and I'm going to do, I'll do 7 here, just because I want another example with that root. So we have 256 to the 3/4 power. The first thing I'm going to do is I have a denominator and with a fractional exponent. So I'm going to take that denominator, it's going to become the index of my root. And we're going to raise this to the 3rd power. So we need to take what's the 4th root of 256? Shoot, I don't even know if I know. It's going to be 4. So the 4th root of 256, so the 4th root of 256 is 4. And right, we can calculate that using a calculator if necessary, or you can kind of mess with it. So what I did, it's just 4 times 4 times 4 times 4 is how I tested it. And I got 256, right? Because the 4th root means there's going to be 4 of them multiplying together. So if I multiply 4 by 4 by 4 by 4, I'll get 256. So that's the idea of the roots there. And this is now 4 cubed, and now I can simply solve this. So this is kind of a quick one. It's going to be 64. So for these, we're just able to multiply my exponents. And then where was the other piece here? Remember, if we have the denominator of the fractional exponent becomes the index of the root, simplify, and it ends up kind of working out for us.